Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Ethernet has become the dominant networking technology worldwide, and its widespread adoption is largely due to its clear set of standards. These standards define how devices communicate, how fast data can move across the cable, and what type of cabling is required. When you plug a computer into a network jack or connect a switch to a patch panel, you're relying on these standards to ensure everything works correctly. The consistency and predictability of Ethernet is what makes it so easy to scale and integrate across different vendors and environments. For the Network Plus exam, Ethernet standards, especially those using copper cabling, are a major topic. You will need to know the various versions of Ethernet, what speed each supports, what type of cable is required, and how far the signal can travel over that cable. These concepts are covered in the physical layer objectives and are tested in many exam questions involving installation scenarios, cable selection, and link troubleshooting. Understanding Ethernet over copper also provides a strong foundation for planning real-world deployments, from home offices to enterprise data centers. The earliest form of twisted pair Ethernet that is still referenced today is 10BASE-T. This standard supports speeds up to 10 megabits per second and uses unshielded twisted pair UTP cabling. It typically requires Category 3 cable or better and operates over a maximum distance of 100 meters. While rarely deployed in modern networks, you may still encounter legacy systems running on 10BASE-T, especially in industrial or specialized environments. Understanding this baseline standard helps when reviewing backwards compatibility and troubleshooting connections that default to lower speeds. 100BASE-TX, sometimes just called Fast Ethernet, is the next step up. It supports speeds of 100 megabits per second and requires Category 5 or better cabling. Unlike 10BASE-T, which could use older phone-grade cable, 100BASE-T was designed with better noise immunity and transmission quality in mind. It uses two twisted pairs of wires, one for transmitting and one for receiving, out of the 4 pairs typically found in an Ethernet cable. Like 10BASE-T, its maximum recommended length is 100 meters, making it suitable for most structured cabling systems. 1000BASE-T or Gigabit Ethernet is a major milestone in Ethernet performance. It operates at 1 gigabit per second and requires Category 5E or better cabling. The key difference in this standard is that it uses all 4 twisted pairs in the cable for bidirectional communication. Each wire pair transmits and receives simultaneously, a technique called echo cancellation. This allows Gigabit Ethernet to run over standard copper cables, making it a cost-sufficient upgrade for networks that already have Cat5 EC cabling in place. When even more performance is needed, 10GBASE-T provides 10 times the throughput of 1000BASE-T, offering speeds of 10 gigabits per second. However, this standard comes with stricter cabling requirements. While it can technically operate over Category 6 cable for short distances, up to 55 meters, it performs best over Category 6A or higher, which supports the full 100-meter distance. 10GBASE-T uses complex signaling and is more sensitive to crosstalk and electromagnetic interference, which is why shielded cables or carefully managed cable layouts are recommended in 10G deployments. To bridge the performance gap between Gigabit and 10GBASE-T, intermediate standards were introduced, namely 2.5GBASE-T and 5GBASE-T. These offer speeds of 2.5 and 5 gigabits per second respectively, using existing Cat5e and Cat6 cabling. These standards are especially useful in environments where replacing existing cabling would be costly or disruptive. Many wireless access points that use Wi-Fi 6 or higher now include 2.5G or 5G Ethernet ports to support higher throughput over familiar infrastructure. Tested for e-speed, touchscreens, and apps on iPhone are all recommended for premium infrastructure. Ethernet also includes support for both half-duplex and full-duplex communication, but full-duplex has become the norm in modern networks. Duplex settings determine whether a device can send and receive data simultaneously. Auto-negotiation is used between devices to determine the highest speed and duplex mode that both ends support. When auto-negotiation fails or is misconfigured, you can experience collisions, slow throughput, or erratic performance. Most managed switches allow duplex settings to be manually configured to prevent such mismatches. One of Ethernet's most convenient features is Power over Ethernet, PoE, which allows power to be delivered along the same twisted pair cables used for data. This makes it possible to power devices like VoIP phones, wireless access points, IP cameras, and even some thin clients without needing separate power supplies. PoE is defined by the IEEE 802.3a/F standard and delivers up to 15.4 watts of power per port. It simplifies installation by reducing cabling, especially in ceiling mount or outdoor deployments where running power is difficult. An 802.3 at standard, also known as PoE+, expands on basic PoE by delivering up to 30 watts of power per port. This supports devices with higher power requirements such as pan-tilt-zoom, PTZ cameras, multi-antenna access points, and certain LED lighting systems. As power demands have continued to grow, especially in smart building systems, a newer standard 802.3 BTs has emerged. This high-power PoE specification, sometimes referred to as PoE++, supports up to 60 watts Type 3 or even 100 watts Type 4 and uses all 4 wire pairs in the Ethernet cable to deliver power. One of Ethernet's greatest strengths is its backward compatibility. Devices that support newer standards can usually auto-negotiate down to older speeds when connected to legacy equipment. For example, a 10G-based T-port can operate at 1 Gbps or 100 Bps if needed. This allows for gradual upgrades, where newer switches and NICs can be deployed even if older cabling or devices are still in use. However, while the ports may support slower speeds, cabling limitations still apply. Using a Cat5 cable for a gigabit connection may result in marginal performance or intermittent failures. Understanding how all these standards relate and which cable types support which speeds is essential for both installing new networks and maintaining older ones. When planning an upgrade, you need to consider what your current cabling supports, what your devices are rated for, and what your performance needs are. For instance, installing Cat6a cabling will allow you to run anything from 100 Mbps up to 10 Gbps, ensuring that the network can grow without replacing the infrastructure again in just a few years. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Ethernet standards rely on baseband signaling, a method in which the entire bandwidth of the medium is used to transmit a single data signal at a time. Unlike broadband, where multiple signals can share the same medium by using different frequencies, baseband dedicates the entire channel to one signal. This approach simplifies signal interpretation and allows for faster encoding and decoding. The specific modulation technique used in baseband Ethernet depends on the speed of the standard. For example, 100 base XT uses MLT3 encoding, while 1000 base T employs 4D PAM5, a more complex scheme that allows gigabit speeds over copper by encoding more bits per symbol and using all 4 pairs in the cable simultaneously. Understanding the limits of cable length is critical when designing or troubleshooting Ethernet networks. For most copper-based Ethernet standards such as 100 base ETX and 1000 base ET, the maximum distance is 100 meters. This distance includes the entire channel, comprising both patch cables and the horizontal run between wall jacks and switches or patch panels. Exceeding this limit may lead to signal degradation, data loss, or a complete failure to establish a link. At higher speeds, such as 10 G base T, the 100-meter limit still applies, but only when using properly rated cabling like Cat6a. With Cat6, the distance may be reduced to 55 meters due to increased attenuation and crosstalk at higher frequencies. Patch panels are a key component in structured cabling systems and play a major role in maintaining organized and high-performance Ethernet infrastructure. Patch panels allow horizontal cabling to terminate at a central point, where shorter patch cables are used to connect devices to switches. This approach provides modularity, simplifies changes, and prevents wear on switch ports. Patch panels also support easier troubleshooting because the cables are clearly labeled and accessible. Well-organized patch panels, combined with horizontal and vertical cable management, reduce strain on connectors and improve airflow within racks. In data center environments, Ethernet standards must accommodate high-density, high-speed applications. While twisted pair cabling is still used, 10G-based T is often replaced by SFP+ transceivers and DAC cables for better efficiency. These options provide lower latency, reduced power consumption, and shorter cable runs, tailored for top-of-rack to aggregation switch links. When twisted pair is used, careful planning is needed to manage heat buildup and electromagnetic interference. Shielded cabling and strict adherence to bend radius guidelines become especially important. The cabling layout must also ensure that hot and cold aisles are not obstructed, as thermal management is critical to maintaining uptime. The Network Plus exam includes several question formats that test your understanding of Ethernet standards. You might be presented with a scenario asking which cable category is required for a 10G BPS connection over 90 meters. The correct answer would be Cat6A, as it is rated for full 10G base tap performance at the maximum Ethernet distance. You may also be shown a network diagram with a cable label and asked to identify the supported speed or whether the configuration can support PoE. Mastering these topics means understanding both the theoretical limits and the real-world implications of cable selection. Troubleshooting Ethernet links often involves examining speed mismatches, cable quality, and device settings. A common issue is when one device is set to auto-negotiate and the other is manually configured, leading to a duplex mismatch. This creates a condition where one device tries to send and receive simultaneously while the other expects alternating transmission, resulting in collisions and poor performance. Another frequent issue is the use of outdated or damaged cables. Even if a Cat5e cable appears intact, internal damage or poor terminations can prevent gigabit speeds from being reached. Using a cable tester to verify continuity, pinouts, and performance levels is a best practice. Link lights and indicators on network interfaces provide a valuable source of information during troubleshooting. A steady green light often indicates a successful link at a specific speed, while blinking may indicate activity. Some interfaces use color coding or dual-color LEDs to differentiate between speeds, such as amber for 100 Mbps and green for 1 Gbps. In cases where no light appears, it may suggest a disconnected cable, failed transceiver, incompatible speed settings, or physical damage. Understanding how to interpret these lights allows for quick identification of the link status before diving deeper into diagnostics. Proper cabling and port labeling streamline both initial deployment and ongoing maintenance. Each cable should be labeled at both ends, indicating its destination and purpose. Labels might include switch port numbers, patch panel identifiers, or the device the cable connects to. Consistent labeling prevents confusion, reduces the chance of unplugging the wrong cable, and helps technicians trace connections when adding or changing devices. Port labels on patch panels and switches should correspond to documented cable maps or spreadsheets, which support both inventory management and fast restoration during outages. Ethernet has continued to evolve to meet the ever-increasing bandwidth demands of businesses and consumers alike. From 10-base T to 1000-base T and beyond, each iteration of the standard has built on the last while maintaining backward compatibility. Technologies such as Power over Ethernet auto-negotiation and baseband signaling have kept copper-based Ethernet competitive, even in the face of growing fiber deployments. While fiber dominates in long-distance and ultra-high-speed environments, copper remains the workhorse of local access networks, thanks to its cost efficiency and ubiquity. In conclusion, Ethernet over copper is a foundational topic in network engineering. It encompasses everything from transmission speed and duplex settings to cable categories, distance limitations, and signaling types. Knowing how Ethernet standards map to cable types and physical environments helps you build reliable, scalable networks. It also enables you to troubleshoot issues effectively and plan upgrades that avoid costly mistakes. Whether you're designing a new network, supporting an existing one, or preparing for the Network Plus exam, Understanding Ethernet over copper gives you the tools to connect devices with confidence and precision. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.